Okay, today we're going to just go back to looking at some perfect squares that we've learnt to expand when we were in term 2 of year 10. So let's look at the perfect square. So let's go generally, let's go a plus b squared. Now when we expand a plus b squared, we learnt that the perfect square was a squared plus 2ab, so twice these two terms together plus the final term squared. Now let's have a look at the coefficients of this particular expansion. If we look at the first coefficient of the first term, we get a 1, then we've got a 2, and then we've got a 1 here. Now incidentally, that's the second row of Pascal's triangle. And I want to just look at this here. This is we were expanding a quadratic, so obviously it's a squared term. What I want to do is just bear this in mind. Let's try expanding a cubic. So I'm going to now expand a plus b cubed. I'm going to have to use the perfect square expansion to help me. So I know that that's a plus b multiplied by a squared plus 2ab plus b squared. So I'm just going to expand that. So obviously the a I'm going to multiply by each of these terms, and then I'm going to do the b with each of these terms as well. So that gives me a cubed plus 2a squared b plus ab squared, and then moving on to the b plus a squared b plus, I'm going to have to move along a bit, plus 2ab squared plus b cubed. Now I'm just going to simplify, collect together those like terms. So I've got a cubed plus 3, so there's this a squared b and this a squared b, so it's 3a squared b. This one here plus this one is 3ab squared, and then plus b cubed. Now let's just look at this end result where we are now expanding a cubic expression. Look at the coefficients of this particular expansion here. 1a cubed, 3a squared b, 3ab squared, and 1b cubed. Now obviously when there's a 1, we don't write the 1. But what we find is that these coefficients here are the third row of Pascal's triangle. Let's have a look at Pascal's triangle quickly, where we've got Pascal's triangle works on a row basis. So this is actually row 0. And this is row 1. And then the next preceding rows are found by starting with a 1 and then adding the previous terms before it together. So row 3 then looks like this: 1, 3, 3, 1. And then if I then add together these two numbers here and these numbers, I get 1, 4, 6, 4, and 1. And we can continue this way where we've got row n, and obviously this is the position. So this is a position, so we call that position R. So if I have a look at expanding a quadratic, sorry, not a quadratic, a quartic, a to the power 4, what I'm going to predict is that the coefficients of that quartic are going to be 1, 4, 6, 4, 1. And R tells me basically what term I'm looking at. So for example, the third term in that expression, 0, 1, 2, 3, will have a 4. We'll start with a 4. So let's have a look. Alright, so let's have a go at expanding a plus b to the power 4. Okay, so I'm going to do two lots of, because I know that a plus b to the power 4 is a plus b squared times a plus b squared. So I'm going to do two lots of the perfect square. So I've got a squared plus 2ab plus b squared, and I'm going to multiply that again by another lot of that. Obviously, it's going to take me a bit of time, and I'll need to simplify my answers. So let's times that by that. So you get a squared times a squared is a to the 4 plus 2a cubed b. So I'm now timesing the a squared by the b squared plus a squared b squared. Now I'll move on to this term here and times that by each one of these two terms. So I've got plus 2a cubed b plus 4a squared b squared. I'm going to have to move along now. And then plus 2ab cubed. Now moving along to the b squared, I'm going to multiply that by each of these three terms. So I get plus a squared b squared plus 2ab cubed. And then finally, b squared times b squared is b to the 4. Now what I'm going to do is collect together those like terms. And what I end up with is a to the power 4 plus, let's have a look, I've got this one here, and if I highlight the like terms there, and this one here, I've got 4 of those, so plus 4a cubed b, and let's highlight in a different colour. Let's go with a cubed, let's see how many a cubed, a squared, b squareds. I've got one there, and one there. So that's 4, 5, 6 of those. So plus 6a squared, b squared. And then finally, how many b cubes have I got? I've got, let's use green for that one and that one. So I've got 4 of those. Just move along, hang on. There we go, plus 4ab cubed, and then finally I've got a b to the power 4. Let's look at the coefficients to see if we predicted correctly. So we've got 1, 4, 6, 4, and a 1. So as we predicted, it is the coefficients of the fourth row in Pascal's triangle.